so fractions still on it. I think this will be like my third day on it. Very important stuff. We can't always assume every time we deal with numbers it's going to be whole numbers, nice clean numbers, 1, 2, 3, 4, 5, stuff like that. Got to know how to deal with everything. So this is what I want to talk about, reducing fractions. Excuse my handwriting. As you can see here, I have a circle cut in half, shaded in one side of it. So we're looking at a fraction of 1/2, 1 out of 2. All right. So what if I cut both of these pieces in half, right? If I cut both of these pieces in half, now what am I looking at? You know what I'm saying? No longer 1 out of 2, is it? So after I cut it down, it went from being 1 out of 2 to 2 out of 4. The only thing that changed is the size of these slices. The whole thing itself didn't change. So 1 out of 2 and 2 out of 4, technically they mean the exact same thing. You saw the shape didn't change, so all we did is recount everything after we sliced it back down. What if I decide to cut this again? So say for instance, I cut these in half again. So I slice one that way, then another one that way. Now what am I looking at? 1, 2, 3, 4, 5, 6, 7, 8. Now I'm looking at 8 with 4 of them being. So you got to follow me now. Now I got 4 out of 8. Remember, we originally were at 1 out of 2. Cut those in half, it became 2 out of 4. Cut those in half, it became 4 out of 8, and so on. All right, and so on. So I'm starting with the 1/2, and I'm building up my equivalent fractions, all right? From 1/2 to 2 out of 4 to 4 out of 8. And if you're paying attention to the pattern, after 4 out of 8, if I cut those in half, it should be 8 out of 16. So I was telling this to one of my other classes. I was saying that mathematics is somewhat like a language, right? So nothing like English. You need to know how to speak English, but the way we do mathematics is not the same way that you would just deal with words. So right now, I say that to say this, like what I was just doing on the board right behind me, I went in one direction. Like I started there, and then I started working my way that way, one direction. In mathematics, you should be able to go forward, backwards, up, and down. So remember, what we really want to talk about today is reducing fractions, all right? What I was doing was not reducing fractions, all right? I was just showing you how these connect to each other as you go up the ladder, right? So I want to use an analogy, all right? So here we go. So no matter if I have 1/2, 2 over 4, or 4 out of 8, they all came from the original fraction, which was 1/2. That's the one I started with, the original fraction. Think of this as a family. 1/2, 2 over 4, 4 over 8. 1/2 is the parent. 2 over 4 is the child. Then what we have right here is the grandchild. You know what I'm saying? But they all come from. When we reduce fractions, all right, reducing fractions, what we're trying to do is figure out who's the parent. Does that make sense? Who's the parent? I can give you a fraction way out here somewhere, but where did it come from? So, for instance, if I give you this fraction, and I'm asking you who's the parent, we got to go all the way back down that family tree, down the lineage to the original fraction. So to get down to the original fraction or to the reduced fraction, you got to use the greatest common factor. Now, that's a killer for some people because you have to know your multiplication facts, right? So there's still another technique that can get you there. If you don't know the GCF, just use sum factors. So all I need to do is multiply things to get 924. Now, this ends in an even number, so I know it's divisible by 2. These last 2 digits is divisible by 4. I know I could either divide by 4 also. So it's up to you if you want to use a 4 or a 2 right now. Now, what I'm doing is the quote-unquote long way, but this is a way that helps out for people that can't stand doing this type of work anyway, all right? So I'm not really focused on the shortcuts right now. I just want to focus on something that may work. So if you're not sure what's going on, this is what we call a prime factorization tree. 2 times 462 is 924, but I can break down 462, 2 times 2, 31. Break that down, 3 times 77. Break that down, 7 times 11. So if I divide this by 2, right, I'm going to get 924. And I think we already can kind of tell if you're catching on something's about to happen. So basically, I ran my prime factorization tree starting with this number and worked it all the way back down. So what I'm left with is a 2 times 2 times 2 times 3 times 7 times 11, all right? So your prime factorization tree, those are the ones that you list across the top for 924, and then the 1828, 1828, you list those all the way across the bottom. So I have a 2 over 2, so 2 divided by 2 is equal to 1. That's a 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 1. Everybody see all the ones? So that is multiplication. So I did put my dots in there. So 1 times 1 times 1 times 1 times 1 is 1. If you look down here, the only thing that wasn't stricken out the list was this 2. So that 2 carries right over. So you got two types of numbers. You have prime numbers. You have composite numbers. Using the prime factorization tree, we're taking composite numbers and trying to break them into all their prime factors. So the greatest common factor would be the quickest way to get to that 1/2, but not too many people off the top of their mind are going to think, okay, maybe 924 is a common factor. Sometimes it's just better to break down all your numbers into factors. So your parent is 1/2, child, grandchild, great-grandchild, great-great, great-great-great, grandchild, right? So reducing fractions is starting way over here and going backward. So I started off building a fraction upwards, right? But now we're talking about coming anywhere within here and going backwards. You got to know how to go frontwards and backwards when you're dealing with numbers in mathematics. So to keep this like in layman's terms, like if you saw a child that was lost somewhere, they were crying, I need to find my mom, my dad. Wouldn't you want to help that child out, locate that parent, right? So in math, we just don't up and say, okay, I'm going to find this fraction and put it over there. We have to verify and make sure that this is actually the parent, right? Almost like DNA. That makes sense? Almost like DNA. So it's almost like DNA, right? Like that's how you're going to know that a child is connected to a parent through its DNA. That's the DNA right there. You get what I'm saying? So your prime factor tree, it gives you the DNA of these numbers here. Once they start striking out, what's going to be left standing is the parent.